Here are the answers for the Day 3 Bell work. Determine the quadrant in which the terminal side of angle theta, which measures pi over 5 radians, lies. To do this, you could look at a picture of a unit circle. Consider one side of the angle to start at the origin and extend straight to the right through the 0. Then, opening counterclockwise for a positive angle, we need to locate where pi over 5 is. We see that pi over 6 degrees is this angle here. Pi over 4 is this angle here. Pi over 5 is going to be in between pi over 4 and pi over 6. So the terminal side of the angle would be a ray from the origin crossing through that unit circle in approximately that position there. This is quadrant number 1 of the grid. You don't have to have a unit circle picture to do this problem. You can make a quick sketch yourself. Here's the y-axis and x-axis. The starting side of the angle will go right along the x-axis. Where's the terminal side of a pi over 5 radian angle? You have to know that a 180 degree angle where the other side points straight to the left is equal to pi radians. Knowing that that's pi radians, you can then split into fifths. So let me just try to approximate 5 equal sections. 1, 2, 3, 4, and 5. I know I don't have those perfectly equal, but it's pretty close for our purposes. So pi over 5 would be out in this direction. And again, that's quadrant 1. Question B, determine the quadrant in which the terminal side of angle theta, which is equal to negative 11 pi over 9 radians, lies. I can bring my unit circle on screen again. Now this is a negative angle, so if the starting side starts at the origin and goes off to the right through the 0, negative angles are when you move around the circle in a clockwise direction. All of these are labeled using positive numbers. On the internet, I couldn't find a picture that had negatives. But when it says 11 pi over 6, if you think of it in the negative direction, that's negative 1 pi over 6. When this says 7 pi over 4, that would be negative pi over 4. If this one is positive 5 pi over 3, the negative angle associated with that is negative 2 pi over 3, and so on. We want to find negative 11 pi over 9. As a mixed number, that's negative 9 pi over 9 and an additional negative 2 pi over 9. Negative 9 pi over 9 is the same thing as negative pi, and then an additional negative 2 pi over 9. So going in the negative direction, when you've made it halfway around the circle, that's negative pi radians. Now we need an additional negative 2 pi over 9. Imagine having that whole top half separated into 9 equal sections and then moving 2 of those 9 sections. We'd be somewhere in quadrant 2. Question C, determine the quadrant in which the terminal side of a 285 degree angle lies. This time it would be helpful to have a unit circle that's labeled in degrees instead of radians. Or you could make a quick sketch. The starting side of the angle points straight to the right. A positive angle opens in a counterclockwise direction. A quarter of the way would be 90 degrees. Going to here would be 180 degrees. Going here would be 270. And then an extra 15 degrees would be 285 degrees. So this angle starting here and swinging around in this direction measures 285 degrees. That's quadrant 4. Question D, sketch this angle in standard position. We know that one side of the angle always starts at the origin and goes to the right. Now we need to locate 5 pi over 4 radians. Let me bring up my unit circle picture. Here is 5 pi over 4, and so we see that the ray splits quadrant 3 right in half. Here's the angle.